Western Front, December 1944. The Ardennes forest. Oberleutnant Klaus Richter had survived 3 years of aerial combat over Europe. He had flown through the hell of Stalingrad's skies, dodged British Spitfires over the Channel, and watched countless comrades fall in burning metal coffins. But nothing, absolutely nothing, had prepared him for what happened on that frozen December night when the Luftwaffe launched what would become known as Operation Bodenplatte. The mission briefing had been clear: strike Allied airfields under cover of darkness and bad weather. For years, night and poor visibility had been the Luftwaffe's greatest allies. The Americans, despite their overwhelming numbers and industrial might, couldn't hit what they couldn't see, or so Richter thought. As his Focke-Wulf 190 screamed through the thick cloud cover at 300 miles per hour, something impossible happened. American anti-aircraft fire found him. Not random flak bursts hoping for a lucky hit, but precise, calculated explosions that bracketed his aircraft with terrifying accuracy in complete darkness, through clouds so thick he could barely see his own wingtips. "They can see us," his wingman's panicked voice crackled over the radio. "Mein Gott, they can see us in the dark." Those would be the last words Richter ever heard from him. A shell burst 20 meters away, and his wingman's fighter disintegrated into a fireball that briefly illuminated the night sky before plummeting earthward. What Richter didn't know, what none of the German pilots knew that night, was that American technological superiority had just reached a level that would fundamentally change aerial warfare forever. The Americans had deployed something the Germans couldn't comprehend: the SCR-584 radar system combined with the M9 director and proximity fuses. Together, these technologies created what German pilots would come to call das elektrische Auge, the electric eye that never blinked, never tired, and never missed. But this story isn't just about technology. It's about American ingenuity, determination, and the overwhelming industrial and intellectual power that won the war in the skies over Europe. This is the story of how American innovation turned the hunters into the hunted and made the night sky, once a refuge for Axis aircraft, into a killing field dominated by U.S. technological supremacy. Part 1. The Dark Ages of Air Defense. To understand the magnitude of what America achieved, we need to go back to 1942. At that time, shooting down aircraft at night was essentially a matter of luck. Anti-aircraft crews would listen for engine sounds, estimate altitude and direction, and fire into the darkness hoping for a hit. The success rate was abysmal, less than 1%. Thousands of shells were fired for every aircraft brought down. The Germans knew this. Their night bombing campaigns over England had exploited this weakness mercilessly. The Luftwaffe could strike under cover of darkness with relative impunity. Even when searchlights caught a bomber in their beams, the time between detection and accurate firing was long enough for skilled pilots to escape. American military planners understood that winning the air war meant solving this problem. While the British had made strides with their chain-home radar network for early warning, actually hitting aircraft with anti-aircraft fire remained frustratingly difficult. Detection was one thing. Accurate targeting was another entirely. That's when American industrial might and scientific genius combined to create something extraordinary. Part 2. The Birth of the Electric Eye. In laboratories across the United States, some of the finest scientific minds were working on a problem that seemed almost impossible: how to track fast-moving aircraft in 3 dimensions, calculate their future position, accounting for shell travel time and ballistic trajectory, and direct anti-aircraft guns to hit them, all in real time. The heart of this system would be the SCR-584 radar. Unlike earlier radar systems, the SCR-584 was a marvel of American engineering. It could automatically track a single aircraft with unprecedented precision. The system used a parabolic dish antenna that could follow targets automatically, providing continuous data on range, azimuth, and elevation. But the radar was only part of the equation. The Americans coupled it with the M9 director, an electromechanical analog computer that was decades ahead of anything the Axis powers possessed. This machine could take the raw data from the SCR-584, calculate where the aircraft would be when shells reached that altitude, account for wind, temperature, and dozens of other variables, and automatically aim the guns. The entire system could track an aircraft, compute a firing solution, and direct multiple anti-aircraft batteries, all without human intervention beyond pulling the trigger. The processing happened faster than any human crew could possibly calculate. It was, in essence, the world's first combat artificial intelligence system. American factories produced these systems by the hundreds, while German industry struggled to manufacture even basic equipment in the face of Allied bombing. American production lines churned out sophisticated radar systems as if they were automobiles. The logistical achievement alone was staggering. Each SCR 584 unit required precise electronic components, specialized tubes, and careful calibration, yet America delivered them to the front lines by the truckload. Part 3. The night Klaus Richter's war changed forever. Back in the cockpit of his Focke-Wulf, Oberleutnant Richter threw his aircraft into a violent evasive maneuver. He had survived this long by being unpredictable. Dive, climb, roll, slip. Never fly straight for more than a few seconds. These tactics had saved his life countless times against British defenses. They didn't work against the SCR 584. The American radar locked onto his aircraft the moment he appeared on its scope at 15 kilometers out. The system tracked him through his evasive maneuvers, continuously updating his position 30 times per second. The M9 director calculated his trajectory, predicted his position, and directed 6 90mm guns to fire in a precise pattern. Richter felt the aircraft shudder as shrapnel tore through his left wing. Another burst exploded directly in front of him, so close that the concussion wave felt like hitting a wall. His canopy cracked. The acrid smell of explosives filled his cockpit. "I'm hit," he screamed into his radio. "Breaking off! Breaking off!" He pushed the stick forward into a steep dive, simultaneously rolling to present a smaller profile. Behind him, 3 more aircraft from his staffel were under equally intense fire. One exploded. Another spun out of control, trailing smoke and flame. The third managed to escape only by diving so low he nearly hit the treetops. Of the 18 aircraft that had launched from their base 2 hours earlier, only 7 would return. Not to enemy fighters. The weather had grounded most Allied aircraft. They had been slaughtered by anti-aircraft fire that seemed almost supernaturally accurate. In the debriefing room, the surviving pilots were in shock. Richter, his hands still trembling, tried to explain what had happened. "They tracked us through the clouds," he said, his voice barely above a whisper. "Perfect tracking, in complete darkness, through weather that grounded our own fighters. It's as if they could see everything." The intelligence officer nodded grimly. They had been receiving similar reports from other units. Something had changed. The Americans had deployed something new, something the Luftwaffe had no counter for. Part 4. The technology behind American supremacy. What the Germans didn't know, and wouldn't fully understand until after the war, was just how sophisticated the American system truly was. The SCR 584 wasn't just a radar, it was the centerpiece of an integrated air defense network that represented the cutting edge of 1940s technology. The system operated on a frequency of approximately 3,000 megahertz, using a microwave radar that could detect aircraft at ranges exceeding 30 kilometers. The parabolic dish antenna, nearly 2 meters in diameter, could rotate 360 degrees and elevate from 0 to 90 degrees, scanning the entire sky. But the real genius was in the automatic tracking feature. Once an operator designated a target, the system locked on and followed it automatically. The radar's continuous wave transmission meant it updated the target's position 30 times every second. This provided an incredibly detailed picture of the aircraft's movement, far more precise than any human observer could achieve. The M9 director then took this data and performed calculations that would have been impossible for human operators. It factored in the velocity of the target, the ballistic characteristics of the shells, wind speed and direction at multiple altitudes, air temperature and density, the Earth's rotation, and dozens of other variables. It did all of this in real time, continuously updating the firing solution as the target moved. The result was devastating. Where previous anti-aircraft systems had hit rates below 1%, the SCR 584 system achieved hit rates of over 70% in ideal conditions. Even in poor weather and at night, conditions that had previously made anti-aircraft fire nearly useless, the system maintained hit rates above 30%. American gunners manning these systems reported an almost surreal experience. They would sit at their stations watching scope displays, while the system automatically tracked and engaged targets they couldn't even see with their own eyes. The guns would traverse and elevate on their own, following the computer's commands. The crew's job was simply to load ammunition and confirm firing authorization. German pilots called it hexerei, witchcraft. How else could the Americans hit what they couldn't see? But it wasn't magic. It was American industrial power, scientific excellence, and technological superiority operating at peak efficiency. While Germany had poured resources into wonder weapons like the V2 rocket, impressive but ultimately ineffective weapons, America had focused on practical technologies that could be mass-produced and deployed where they mattered most, in the hands of soldiers on the front lines. Part 5. The Strategic Impact. The deployment of the SCR-584 system had effects that rippled far beyond individual engagements. German tactical doctrine had to change overnight. Night and bad weather operations, previously considered safe, became suicide missions. The Luftwaffe, already struggling with fuel shortages and pilot losses, found its operational effectiveness cut in half. American air bases, supply depots, and troop concentrations that had required massive allocations of anti-aircraft guns and fighters for protection could now be defended by a handful of SCR-584 batteries. This freed up resources for offensive operations. American fighters that had been tied down in defensive patrols could now be released to escort bomber formations or conduct ground attack missions. The psychological impact on German pilots was equally significant. Klaus Richter would fly 12 more missions before the war's end, but he was never the same pilot. The confidence that had sustained him through years of combat was gone. He flew scared, constantly expecting the sky to erupt in perfectly aimed flak bursts. He survived the war, but many of his comrades didn't. The Luftwaffe's loss rate increased dramatically in the war's final months, and the SCR-584 was a major factor. After the war, captured German documents revealed that Luftwaffe intelligence had correctly identified the SCR-584 as a major threat, but had vastly underestimated both its capabilities and the scale of its deployment. German reports estimated the Americans had perhaps 20 or 30 such systems. The actual number was over 1,500 units deployed in the European theater alone, with thousands more in the Pacific and defending the continental United States. This wasn't luck. This wasn't about having a few brilliant scientists who invented something clever. This was about America's unique ability to take cutting-edge technology and produce it at industrial scale. It was about having the manufacturing capacity, the trained workforce, the raw materials, and the logistical infrastructure to deliver sophisticated equipment to the front lines faster than the enemy could develop countermeasures. The Germans had talented scientists and engineers. They developed jet aircraft, cruise missiles, and ballistic rockets, but they couldn't produce them in meaningful numbers. Their industrial base was under constant attack. Their supply lines were disrupted, and their economy was collapsing under the weight of total war. America, by contrast, was an industrial colossus operating at full capacity, protected by 2 oceans, with an economy that grew stronger throughout the war. American factories didn't just produce more, they produced better. The SCR-584 was more reliable, more accurate, and easier to maintain than any comparable Axis system. When units broke down, spare parts were readily available. When new tactics required modifications, American engineers could implement changes and deploy upgrades within weeks. Part 6. The men behind the machines. But technology alone doesn't win wars. Behind every SCR-584 system were American soldiers who operated, maintained, and deployed these sophisticated machines under combat conditions. These weren't rear-echelon troops sitting in comfortable positions. They were on the front lines, often under fire themselves. Staff Sergeant Mike O'Brien was one of these soldiers. A radar operator from Chicago, O'Brien had been trained on the SCR-584 at Fort Bliss, Texas, before shipping out to Europe in early 1944. His battery had been deployed to protect a critical supply depot near Bastogne during the Battle of the Bulge. We could see them coming from miles away, O'Brien recalled years later. These little blips on the scope moving across the screen. The system would lock on and we'd watch as the director calculated the solution. Then the guns would start tracking automatically and we'd get the fire command. It was like something out of science fiction. But operating the system under combat conditions was far from easy. The equipment required constant maintenance. Vacuum tubes burned out and needed replacement. Calibration had to be checked regularly. The generator that powered the system was temperamental and required careful monitoring. In the bitter cold of that December, O'Brien and his team worked around the clock to keep their radar operational. The Germans didn't know exactly where we were, but they knew we were effective, O'Brien remembered. They started targeting radar positions with artillery. We lost good men. But we kept that system running because we knew every plane we knocked down was one that couldn't bomb our guys, couldn't strafe our positions. This was the reality of American technological superiority. It wasn't just about having better equipment, but about having soldiers trained and dedicated enough to use that equipment effectively under the worst possible conditions. The American military didn't just hand out sophisticated weapons and hope for the best. They trained soldiers extensively, provided detailed technical manuals, established robust maintenance protocols, and created supply chains that ensured spare parts and support were always available. Part 7. The Final Reckoning. By March 1945, the war in Europe was entering its final phase. The Luftwaffe was a shadow of its former self. Fuel shortages grounded most aircraft. Experienced pilots had been killed or captured, and anywhere Allied forces operated, the sky was dominated by American radar systems that made daylight operations suicide and night operations only marginally better. Klaus Richter flew his last combat mission on April 3, 1945. By this point, the mission was essentially pointless. Germany had lost the war, and everyone knew it. But orders were orders, and pilots still flew. His target was an American supply column advancing toward Munich. He and 5 other pilots took off at dawn, flying low to avoid radar detection. They never reached their target. An SCR-584 battery picked them up at 12 kilometers out. The American gunners had become extremely proficient with their systems over months of combat experience. They knew the tactics German pilots used to try to evade tracking. They knew how to predict evasive maneuvers and adjust their firing accordingly. Richter's aircraft was hit before he even saw the supply column. Shrapnel tore through his engine and smoke immediately began pouring into the cockpit. He had seconds to decide, try to make it back to base or bail out over enemy territory. He chose to bail out. At low altitude, it was a dangerous decision, but staying with a burning aircraft was certain death. He pulled the canopy release, struggled against the slipstream, and threw himself clear of the doomed fighter. His parachute opened barely 200 meters above the ground. He hit hard, rolled, and lay in a muddy field, staring up at the sky where his aircraft spiraled downward before exploding in a plume of black smoke. American soldiers found him 20 minutes later. He expected harsh treatment. Nazi propaganda had painted the Americans as barbaric. Instead, medics treated his injuries, gave him water, and transported him to a POW facility where he received the same medical care as wounded American soldiers. In the prisoner compound, Richter met other captured Luftwaffe personnel. The conversations always came back to the same thing. How had the Americans achieved such technological dominance? How had they produced such sophisticated equipment in such vast quantities? An older pilot, a veteran of the First World War, who had been recalled to service in 1943, put it succinctly, "We fought yesterday's war with yesterday's thinking. The Americans fought tomorrow's war with tomorrow's technology. We never had a chance." Part 8. The Legacy of American Innovation. The SCR-584 radar system and its associated technologies represented more than just a tactical advantage. They represented a fundamental shift in how wars would be fought. For the first time in history, defending forces could engage attacking aircraft with precision in any weather, at any time of day or night. The technology that had given bombers free rein over the battlefields of World War I was now obsolete. After the war, captured German scientists and engineers were given access to American radar systems as part of their debriefing. Their reactions were consistent: shock at the sophistication of the technology, amazement at the scale of deployment, and grudging admiration for the industrial capacity that had produced thousands of these systems while simultaneously fighting a two-front war across 2 oceans. The SCR-584 technology didn't end with World War II. It formed the foundation for post-war air defense systems that would protect America and its allies throughout the Cold War. The principles of automatic tracking, computer-assisted fire control, and integrated air defense networks that were pioneered in those systems continue to this very day. Modern air defense systems like Patriot and Aegis are direct descendants of the technologies first deployed in the SCR-584, but perhaps the most important legacy was the demonstration of American capability. The SCR-584 showed the world what America could achieve when its industrial might, scientific talent, and national will were focused on a common goal. It wasn't the atomic bomb. That came later. It wasn't a superweapon that ended the war in a single stroke. It was a practical, effective system that saved American lives, destroyed enemy aircraft, and contributed directly to victory. This is what American technological superiority looked like in World War II. Not flashy wonder weapons, but robust, reliable, mass-produced systems that worked. It was the victory of American pragmatism over German perfectionism, of quantity with quality over quality without quantity. Klaus Richter survived the war and returned to Germany in 1947. He never flew again. In his later years, he would occasionally speak at schools about his experiences. When students asked him why Germany lost the war, he would point to many factors: strategic mistakes, resource shortages, fighting on multiple fronts. But he always came back to that December night in 1944 when the sky erupted with impossibly accurate anti-aircraft fire. "That was when I knew we had lost," he would say. Not because of one battle or one defeat, but because the Americans had reached a level of technological capability we simply couldn't match. They could see in the dark, calculate faster than any human, and hit targets we thought were invisible. How do you fight an enemy that can do that? The answer, of course, was that you couldn't. Not against the United States of America, with its unmatched industrial capacity, its scientific excellence, and its determination to develop and deploy the best technology in the world. The SCR-584 wasn't the weapon that won World War II. No single weapon was. But it was a perfect example of American ingenuity, American power, and American determination to achieve victory through technological superiority. It turned the night sky from a refuge into a killing field, and in doing so, helped bring the war to a swifter conclusion and saved countless American lives. That December night, when Klaus Richter watched his wingman die in flames and felt his own aircraft shudder under perfectly aimed anti-aircraft fire, he was witnessing more than just effective air defense. He was witnessing the future of warfare, a future dominated by American technology, American power, and American supremacy in the skies. The German pilots couldn't believe their eyes because they were seeing something that shouldn't have been possible with 1940s technology. But it was possible. America made it possible, and that made all the difference. Epilogue. The SCR-584 system remained classified until 1947. When details were finally released, they stunned the scientific community worldwide. The system had been so far ahead of its time that even years after the war, it represented cutting-edge technology. The Soviets spent decades trying to replicate its capabilities. Many nations never succeeded in developing equivalent systems. Today, the few surviving SCR-584 units sit in military museums, silent testaments to American innovation during the most critical conflict in human history. They don't look impressive to modern eyes, bulky equipment with vacuum tubes and mechanical computers that modern smartphones dwarf in processing power. But in their time, they were revolutionary. They were the electric eyes that never blinked, the invisible guardians that protected American soldiers from enemy aircraft, the technological triumph that helped win the war. And they were proof that when America commits its full resources to a challenge, when American industry, American science, and American determination unite toward a common goal, nothing is impossible. That's not propaganda. That's history. And Klaus Richter, if he were still alive, would be the first to tell you it's true.